Hey guys, so here's part 4. We're going to once again do function operations, so adding and subtracting, and determining the domain. Okay, so don't forget, anytime we need to find the domain, we need to do it before simplifying. So I'm going to write this again. So before simplifying, find the domain. And that's going to be the same case here. So we basically just put it, what the f of x and g of x, we write that down, but then we find domain, and then we do either adding or subtracting. Okay, so our first one, we have f of x. Now notice we now have multiple terms here. We have negative 3x to the 1/2 plus 4x to the 1/3. And we're adding that, I'm going to put that in parentheses, so I know that's my f of x, with the 5x to the 1/2 plus 3x to the 1/3. Okay? Now, before I actually add and do all my simplifying, I need to determine the domain. Now, you will see here there is a mixture of both even and odd rational exponents. Now, when this happens, because remember, if we're thinking what x values work, we would have to plug the same x value into all of these x's. So let's say I pick a negative number. Now, would a negative number work and then negative 3x to the 1/2? No, because notice my 1/2 is an even rational exponent, and negative numbers don't work for our evens. Now, if I plug a negative into 4x to the 1/3, yes, it does work because we can take the cube root of a negative. You can really take the odd root of any negative. But what about the 5x to the 1/2? What if I plug a negative number into there? No, that does not work because we have an even rational exponent. But if I plug it into the 3x to the 1/3, it does work. A negative number does because we can take the odd root of a negative. Now notice though, on some of these, negative numbers doesn't work. So when you are thinking what x values work, they have to satisfy all of the terms here. So since negative numbers don't satisfy all 4 terms, we actually can't have negative numbers as part of our domain. Now let's talk about 0. Can 0 work for all of these terms, meaning I get a real solution? Yes. If I just plug 0 into all of these x's, I just get 0, and 0 is a real number. What about a positive? Well, positive numbers work for everything. So yes, they work for all 4 terms. So anytime you have a mixture of both even and odd rational exponents, your domain will still actually look like just the even rational exponent domain. So we're only really going to go from 0 to positive infinity because those are the numbers that work for all 4 terms. Now that we determine our domain, I'm going to go ahead and simplify. So I need to combine my like terms. So my negative 3x to the 1/2 and 5x to the 1/2, they are like terms because they have the same base, x to the 1/2. So I combine the coefficients, negative 3 and 5, to give me 2x to the 1/2. Now I do the same thing with my 4x to the 1/3 and 3x to the 1/3. Well, since their base is the same of x to the 1/3, I combine the coefficients, so 4 and 3, and I get 7x to the 1/3. And since I can't combine anything else, because I don't have any more like terms, that will be my final answer. Okay, let's look at f of x minus g of x. So I have my parentheses of negative 3x to the 1/2. Plus 4x to the 1/3. Now subtraction, so we got to be careful with that. 5x to the 1/2 plus 3x to the 1/3. Right? Yes. Okay. Now, as I said before we simplify, we need to find the domain. Now, once again, notice this is a mixture of even and odd rational exponents. So anytime you have a mixture of even and odd rational exponents, the domain is just going to be the same as if it was just an even, because 0 and positive numbers are the only numbers that work for all the terms. So I'm going to have bracket 0 to infinity, and that'll be my domain. Now, I need to make sure this negative, I'm going to go and simplify, I change this into a positive, and I'm going to go ahead and change all the signs behind it to negative. Basically, what I did was I distributed my negative sign. Okay. So when I do that, I combine my negative 3x to the 1/2 and negative 5x to the 1/2. So now I get negative 8x to the 1/2. And then 4x to the 1/3 minus 3x to the 1/3, I get plus x to the 1/3. And so there's nothing else I can combine because I don't have any more like terms. This will be my final answer. Okay, let's go ahead. We're going to do our last one. I would like you guys to go ahead and pause the video and try this one on your own. Okay, let's see what you got. So, yeah, I want to make sure I have enough room here. Okay, so we have g of x this time. So our g of x is going to be that, let's see if I can go back to remember, 5x. Okay, so we have 5x to the 1/2 plus 3x to the 1/3, and then minus, there was negative 3x to the 1/2, and then plus 4x to the 1/3. Now, before I simplify, once again, we have a mixture of even and odd rational exponents. So that means my domain is going to be exactly the same as it has been for the past two. We're going to go from 0 to infinity. Now I go ahead, I distribute my subtraction and change all the signs behind it. So now I want to combine my like terms, so I do 5x to the 1/2 plus 3x to the 1/2. That gives me 8x to the 1/2. And then I combine the 3x to the 1/3 with the negative 4x to the 1/3, and that gives me negative x to the 1/3. So remember, you're only combining those coefficients. The base stays exactly the same, and that will be your final answer. Okay, make sure if you have any questions that you contact me, and make sure you work on that homework assignment. I'll see you guys later.